team we are looking at. We are going to be determining up to this point, all of our x squareds when we've been solving have not had a middle term. So now we're going to be looking at equations for quadratics where we have that middle term. We're going to think about factoring. Factoring is what we did in our last unit H when you had and multiplied. And you might have started with x, and then you had to multiply these two together, had to multiply to give you your last number and add to give you the middle. So that's how we're going to look at these two down here, factoring. If it's in standard form, sometimes we're going to try and we're trying to find the zeros or roots in our equations. So as you are looking at these, remembering that the zeros or roots are also the same as your x-intercept. So if we are going to factor these, please put 2 parentheses. We are trying to multiply to equal 10, and it has to add to -7. And it has to multiply to give us x squared, so that's kind of nice. X times x gives us x squared. Multiplying to 10, 5 and 2, and -5, and -2, and that adds to -7, my middle term. Now, this next one, when I look at factoring it, this is where we use that AC method, right? So this is going back to some of our earlier lessons. So we have to take 2 times -3. That's that AC. This is our A, and this is our C. That gives us -6. So it has to multiply to -6, and it has to add to 1, which instead of 2 and -3, we're going to go with what? -2 and +3. So this is, remember when we did the factoring, those of you not writing, write it down, 2x squared. We might have a -2x, then a +3x. That does add to 1x, which is our middle term. And then we are going to have still a -3. So remember, the only thing you're changing is that middle term. And now you're factoring your greatest common factor. And our greatest common factor in the first two is 2x. And that'll leave us with x minus 1. And in these two, I take a look and I have 3x minus 3, so the greatest common factor is a 3. And I'm going to be left with x minus 1. So when I write my factors here, it is x minus 1 times 2x plus 3. Now, if some of you in letter H don't remember your factoring and doing these problems, okay, at this point, what we are going to be talking about, so it says what we learned in I2 is that there's 3 forms of quadratics. There's standard form, there's vertex form, we are now in factored form. Today we are looking at factored form because this is the easiest way to solve. So they took off all my forms that I had on the board, but those are going to be, this is going to be the form that we are going to look at because these are the roots or when we were looking at our equations. So here's that zero product property. It says that we can use this property to solve our quadratics when they are in factored form. Factored form is when you have 2 things being multiplied equal to 0. Now keep in mind, factored form would have been, if I'm looking at my equation, this is what I had up on the board, A minus R1, or I think usually they have x minus R1, and x minus R2, R sub 2. Those are my 2 roots, and notice my equation was equal to 0. And when y equals 0, that's when you have x-intercepts. So it says we use the zero product property to find what each variable is equal to. So if we were just going to solve this, 5 times g equals 0, g would equal just 0, right? 5 times what equals 0? G has to be 0. If x times y equals 0, that means that either x equals what? 0 or y is equal to 0. If x doesn't equal 0, y can be, if x does equal 0, y could be anything, right? If y equals 0, we don't care what x is, because as long as one of them equals 0, it'll multiply to equal 0. So then we look at this next one. Can 3 ever be equal to 0? No. So we're going to put k minus 1 equals 0. if k minus 1 equals 0, we are going to add 1 to both sides, and k equals 1. So if I have 1 here, this will equal 0. The question is, what could p plus 1 and r minus 4 be so that it equals 0? So you're going to set each parenthesis equal to 0. And you're going to solve them. And they're usually pretty simple linear equations that you're solving. So here you're subtracting 1 on both sides, so p equals negative 1. Here you're adding 4 on both sides, and r is equal to 4. Don't write too much. No, it's hard sometimes to write all this. So when we are looking at those, you're going to be asked to solve. These are kind of the roots. These are the solutions to our quadratics that we are going to be looking at. So this is now that factored form of our equation. And it says that 4t plus 1 and t minus 2 are both equal to 0, because those equations where we're looking at time and height, right? So this might be how we factor that equation. And it says, how much time does it take? So you're going to set each parenthesis equal to 0. That's what our zero product property tells us to do. Here we're going to subtract 1 and divide by 4. One answer is t equals negative 1/4 and t equals 2. If I was looking at those as roots, okay, t equals negative 1/4, that's like right here. T equals 2 is like over here. If I'm looking at this parabola, do we think this parabola goes up or down if I would have multiplied this out? What would I be looking at? My t squared, would it be positive or negative? This t times 4t times t would have given me a 4t squared. So if I was replacing this 0 with y equals, this would have been 4t squared. What would be my middle term here? 4 times negative 2 would give me negative 8, plus 1 would give me a negative 7t. 2 times negative 2 times 1 would give me. So this is the same equation, it's just written in standard form. So this parabola would have been down here, right? The parabola that goes up. We don't know we didn't find our axis of symmetry or anything like that. But this is the 1/4 that we are looking at. T equals 1/4 or negative. In this case, that x is equal, and here is our positive 2. Now, the nice thing about these is if you're just asked to solve a quadratic, if it's already factored, which you'll see one like this on your quiz and on your test, and I'll have people multiply it out. All you have to do is take 2x plus 3 equals 0, and x minus 4 equals 0. Solve both of those, please, if you would. We can keep them as fractions. 2x plus 3 equals 0. What are you going to do first?
Subtract 3 from both sides.
Subtract 3 both sides. We get 2x equals negative 3. Then what?
You do 2 divide by 2 on each side.
Divide by 2. So our first answer is x equals
Negative 3 over 2.
negative 3 over 2. Could someone else write it as negative 1.5? Same thing. Okay. Emily, if I'm looking at the x minus 4 equals 0, what do I have to do to solve it? Add 4. Add 4. So if I add 4 to both sides, x equals 4, right? Adding 4 to both sides, x equals 4. So when I look at my solution here, my two solutions that I'm looking for are x equals negative 1/2 or x equals 4. Those are my two solutions. If we keep going, Brody, over here, we're going to start solving. If I'm solving for 7n minus 2 equals 0, I'm going to start and have add 2. So 7n equals 2. Next step, Laura, is if I have 7n equals 2 is to divide by 7. One solution is n equals 2/7. On the other side of that, if I am looking at solving, Freddie, I'm going to do what? 5n minus 4.
5n.
First step is add 4. So we get 5n is equal to 4. Next step, Aiden, is going to be,
You divide 5 to both sides.
so I have n equals 2/7 and n equals 4/5. I can write it like this with a comma. This is why I was so picky earlier this year when some of you wanted to tell me an ordered pair and you didn't put a parenthesis, is because now we have two solutions for our problems. And so this is not an ordered pair. These are like what x equals, or Those are my roots. So I do not want this as with a parenthesis around it in this case. So on the top of the next page, as you are looking at this equation, it says m minus 5m minus 14 equals 0. What method can we use to solve it? Method 1 would be, as we take a look, could we use square roots? In this case, since we have a middle term, we cannot. If it would have just been m squared minus 14 equals 0, and you had this no negative 5n, you could have solved it. Method 2, we could graph it. We could. It's usually not easy, and if you have to do that, you have to find those vertex points. So at this point, what we want to do is factor. If it's not in factored form, you can fix that. You want to rewrite the equation in factored form and then solve it using the zero product property. So if you have a middle term, this is what we want to look at. So this one's pretty easy to factor, right? If we're looking at it, Benson multiplies to negative 14 and adds to negative 5. What are we looking at?
Negative 7 and 2.
So I'm going to have m minus 7 and I'm going to have m minus 2. Is that going to work?
No, it's going to be plus 2.
Yeah.
Plus 2. Has to multiply to negative 14. Negative 7 and 2 does that. And add to negative 5. Negative 7 plus 2. So those are my middle terms. Next thing we're going to do is we're going to set each parenthesis equal to 0. So m minus 7 equals 0. And plus 2 equals 0. Once I've done that, Angus, the first one when I solve, m is going to equal 7. Second one when I solve, as I'm looking at it, Evan. What's that? Or m equals negative 2. And you can write it out like this, or you can just write your answer as m equals, and when we are looking at it, you can have those two solutions. So you might write it, some of you will prefer to write it this way, m equals 7 or negative 2. Okay? So when we are looking at it, here's the key thing. To use this method for your equation, it must be in standard form or equal to 0 before you factor it. So the key thing is, has to equal 0. So some of these equations that you're going to see on the next page are not equal to 0, and we need to set them equal to 0 first. So p plus 5, that gives us n minus 4. You're going to set each one equal to 0, so you're taking p plus 5, setting it equal to 0, and p minus 4 equals 0. If I do that, Elise, I'm going to have p is equal to, or p equals negative 5, or p equals 4. You can write it this way. You can put p equal for each one. As we start factoring here, so Jack, it has to multiply to 36, so we're looking at numbers that multiply to 36, but could add to negative 15. Okay, so let's think of, we have 218 is going to be, if we're looking at those factoring that, we might have had 2 times 9 or 3 times 3. Those are my prime factors that I got to use, okay? So 2a squared, any combination that you can see. If we are looking at that, because they both have to be negative, because this is a positive 18. So which one did you say you wanted to go first with? 12. So minus 12a minus 3a. 12 times negative 3 is still going to give us the 36. And then we have plus 18 equals 0. Okay? We are going to factor our greatest common factor, Lizzie. So as we factor our greatest common factor in that first one, what do you have?
1.
How about 2? They at least have a 2 in common, right? 2 and 12.
Oh,
So 2a squared, yep. 2 and what?
2a.
Yep, leaving us with?
A minus 6.
Yep, counting in that second one, we're factoring out
3.
3. Now if I just factor a 3, I'm going to have a negative first and then a plus, but I want it to be a minus 6. So I'm going to factor out instead negative 3. Leaving us with? A minus 6 equals 0. Okay, Lulu, you ready? Okay, factored form is?
2a minus 3, and then 6a minus 6.
Okay, so we're setting them equal to 0. So Emma, when I set each of these equal to 0, 2a minus 3 is going to equal 0, and a minus 6 equals 0. What am I getting for solutions? A is equal to? Okay, the second one's easier, right? A equals 6, or What else, Wyatt? She solved the second one. She did this one first. It was much easier. If I set 2a minus 3 equal to 0, what are you going to do first to solve that? Add 3, so 2a equals 3. And then what? Divide by 2. So a is going to equal 6. That's for this part. And over here, it's going to equal 3 halves. Could I have 1.5? I could have 1.5 instead if I wanted to. Okay? So Christian, we're start working on this next one. It's not equal to 0. So the most common mistake people want to start factoring as it is, but we're going to set it equal to 0. So equal to 0 is going to become x squared plus 14x. And if it's equal to 0, what do you have to do with the negative 49? I had to add 49. Right? I added it to both sides, and that gave me equal to 0. So all of a sudden you're looking at these and you're thinking about the last unit and you're thinking, oh, 49 is such a beautiful number. It's one of our perfect numbers. It's a perfect square. So Kristen, we're looking at it and we're thinking, oh, how could I factor two things that multiply to 49 and add 14? 7 and 7. Could I go with x plus 7 and x plus 7 instead of writing this? Instead of going x plus 7 squared? Yeah, you can do this. These mean the same thing, right? So if you have the lead coefficient as a 1, like in x squared, you can do this. And now, what's going to happen when I put x plus 7 equal to 0? X is going to equal? And what's going to happen when I set this one equal to 0? 7. So you only have one solution, right? This answer, these two are going to give you the same solution. So I really don't have to set this equal to 0 because x plus 7 equals 0 is still going to give me this answer. Both gave me that answer. Why? That vertex is where? That vertex, if you're thinking of it, is over at x equals negative 7, and my parabola is something like this, right? Where that parabola is either going up or going down, and it's way over at negative 7, 0. And that is my only solution to that problem, right? That's what we are looking at. Now, this next one's kind of a story situation that you're going to look at. You'll see this in your homework. We're going to be looking at those equations where we're looking at time also. But this one says you're constructing a frame for a rectangular photo show. So you want the frame to be the same width all the way around. That total area of the frame is going to be 391 inches squared. What are the outer dimensions of the frame? So first off, if I'm looking at the picture's area is what? 11 by 17, right? So we could find that area, but we don't want that. What is the length of this whole side? It is 17 plus how many x's? 2. 2. So 17 plus 2x. Could we write it instead as 2x plus 17? A lot of times we put the variable part first of that. What is the length of this side going up? It's 11 plus how many x's? The frame up here is x and down here is x. So it's, again, 2x plus 11. This is kind of ugly. And this one does take a lot of multiplying. You have to multiply, then you got to factor, and it's a little ugly. But so we are going to start with our area of our frame is 2x plus 17 and 2x plus 11. And the area of the frame was 391. You have to multiply this out using either your box method or FOIL or that distributive property. So 2x times 2x, as I'm multiplying that, is going to give me 4x squared. Then I'm taking 2x times 11. 2x times 11 is going to give me 22x. You're going to take 17 times 2x, which gives us 34x. And then 17 times 11.
176.
We have to get it equal to 0. We're going to subtract 391 and we're going to add our like terms. My like terms are these two x's in the middle. So I now have 4x squared plus 36x.
No. 56x. And then 187
minus 391 is gonna leave us with a negative or a minus.
4.
So, first thing I wanna look at, do we have a greatest common factor?
Yes.
4.
Yeah. 4x.
Or no, they don't all have x's. So,
That is wrong.
pretty easy. This first one's gonna be x squared. 56 divided by 4 gives us 14x. 204 divided by 4
101.
gives us 51.
100.
So you're dividing each one by 4. Okay? So Almudine, I want to be thinking if possible, multiply 51 and add to 14, and I'm going to factor with 2 parentheses. Now there's not a lot of options to get to 51, and 3 is a factor. So 3 times, use your calculator, 51 divided by 3 for looking. We're going to have x and x. Which one needs to be positive, which one needs to be negative? Right. 3 is negative, so x minus 3 and x plus 17. Can you set this 4 equal to 0? Do we have to set it? And 4 is never going to equal 0, so you can't. So you're going to set the x minus 3 equals 0. X minus 3 equals 0, and x plus 17 equals 0. Okay? This is a lot. So what are my solutions? X is equal to 3 or negative 17. And we got to think about which ones make sense, right? So in this case, x is equal to 3, we would have, and negative 17. But the question never asked us what x was equal to. The question says, what is the outer dimension of the frame?
3.
So, if you use x is 3, one of the sides, right? Here's one of the sides of your frame. One side of the frame was equal to 2x plus 17. The other side of the frame was 2x plus 11. And here's the deal. When you look at this equation, what is never going to happen here is that we can't have the negative 17. Our only solution is going to be that we use x equals 3. Because if you try and plug in negative 17 for x here, you're going to get a negative dimension. You can't have a negative dimension. But when you plug in 3 into those two equations, the first one, when you plug in 3, as you look at that, you're going to have 2 times 3 or 6 plus 17. Here you're going to have 2 times 3 or 6 plus 11, and your two dimensions are 17 and 23. How did we get our dimension of 23? Because we were looking at 2 times 3 plus 17. This one was 2 times 3 plus 11. That was our width that we were looking at. Okay? So as you are looking at your